Good morning to one and all. We begin today with a thought that truly encapsulates the spirit of gathering. As the saying goes, knowledge is the currency of 21st century and the research is the engine that creates this wealth. Research is the compass and innovation is the path towards the future we envision. On the behalf of the Pranveer Singh Institute of Technology, we extend a warm and delightful welcome to this day 2 of this prestigious international conference on emerging technologies in automation, computation and electronics, EACE 2025. Yesterday was a day filled with intellectual brilliance, inspiring knowledge and technological breakthroughs. This international conference is a dynamic platform that brings together scholars, researchers, academicians, and industry experts. Our goal is simple yet profound to share cutting edge advancement across several crucial domains. We now extend our heartfelt and special welcome to our special dignitaries. Esteemed Group Director Dr. Manmohan Shukla sir, respected Director PSIT Professor Raghven Singh sir, respected Director Academics PSIT Professor Vishal Nagar sir, respected Director PSIT CHE Professor Harit Kumar sir, respected Director Pharmacy Professor Pranay Vyal sir, respected Additional Director PSIT Professor Raghuraj Singh Suryavanshi sir, and all our esteemed keynote speakers, all deans, HODs, faculty members, and all my dear colleagues. We are profoundly grateful to your esteemed presence, which has added an immense value to this academic gathering. Your participation makes EACE 2025 a truly enriching and a memorable experience. Ladies and gentlemen, before we officially begin with our expert sessions, we have a simple but a significant tradition. A plant or a sapling is a symbol that symbolizes growth, knowledge, and nurturing of a vision. So, in this spirit, now may I request our respected Director PSIT, Professor Raghven Singh sir, to give a sampling to our respected keynote speaker, Irshad Ahmed Ansari sir. Everyone, please give a background applause. Thank you so much, sir. And now we are going to begin with our insightful keynote sessions featuring renowned experts shaping the world of technology. A great keynote doesn't just speak, it sparks vision. So here we are going to welcome our first keynote speaker.
Good morning, everyone. Dr. Irshad Ahmed Ansari sir has been a faculty member in electrical and electronics engineering at the ABV International Institute of Technology Management in Gwalior, India since June 2023. He received his BTech degree in electronics and communication engineering from Gautam Buddha Technical University in Lucknow, India in 2010 and his MTech degree in control and instrumentation from Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab in 2012. He completed his PhD from IIT Roorkee with an MHRD teaching assistantship in 2017 and consequently he joined Gwangju Institute of Science and Technology in South Korea as a postdoctoral fellow. Afterward, he joined the PDPM Indian Institute of Technology, Design and Manufacturing in Jabalpur as an assistant professor. His major research interests include signal and image processing, electronic design, machine learning, and biomedical signal processing, and computer vision, etc. He is contributing active technical reviewer for leading international publishers including IEEE, IOP, Elsevier, and Springer. He has more than 100 publications to his credit and the citation impact of his publication is around 2000 citations with a H-index of 24. He has guided 6 PhD scholars and 8 MTech scholars to date. In October 2023, he was listed as the world's top 2% of the researchers by Stanford University in USA. He has two published patents and 6 edited books to his credit. He has received 4 competitive research grants from different organizations, including IISc Bangalore and ISRO Ahmedabad. Now, I would like to request everyone to kindly join me in welcoming our respected sir.
Okay, thank you very much. So, today I am here to present the topic Intelligent Biomedical Signal Processing, and it is one of my key research area also. Along with this, I also work in the area of image processing. So, the very first question over here is that what intelligent can do with biomedical signal processing and why biomedical signal processing is even needed. Okay, so that is the key question that we are going to answer today. We try to find out the answer today actually, because it's a constant research. So with time, what happened that new things keep on coming and we try to incorporate those things in our research. That's how basically research work. Okay, so that's what we try to see, that what are the current challenges and what are the future research direction and what is the current state of the art. So all of these things we are going to now club together and try to see that where we are standing today and where we should move next. Okay, so that's what we are going to explore in this talk. Now before I start my presentation, I just want to give you a brief about my institute where I am working right now. So this is the first institute in terms of triple IT, okay, founded in 1997 by MHRD. Now it is known by the Ministry of Education, and along with that we have also got the status of Institute of National Importance in 2014. Okay, so it is one of the Institute of National Importance which deals in technology, mainly information technology and the management part. So these are the two things. In addition to that, I basically belongs to the department of EEE, the Department of Electrical and Electronics, okay, where we deal with all the areas of EEE, like electronic circuits are there, analog circuits, digital circuits, signal processing, biomedical signal processing, communication, networking. So all different type of areas we are dealing with. Okay. Okay. So what else we have is, we have BTech program, MTech program in all the different disciplines, but I am just going to tell about my EEE department. So we are offering BTech program in EEE department, and the offering that we basically provide is in the EEE, Electrical and Electronics Engineering. The admission is through JEE. Then after we have one MTech program in Autonomous and Machine Intelligence. So this is one of the unique program that might be interest of some of you also. Okay, so this basically deals in the EV domain and drones, okay, and how different autonomous system basically works. So in that particular domain, this program basically deals in. And in addition to that, we have PhD in all the areas. In MTech program, we do take GATE, and beyond GATE we also take non-GATE students also. So if seat remains open, then only it is possible, but yeah, it is there. Okay, so just I'm telling you a brief. A few of you might be interested, so that's why. Okay, now coming back to our main topic. What the topic is? The topic is intelligent biomedical signal processing. Okay, so now this scene, as you can see, Virat Kohli is basically wearing a vest. Okay, So this vest, as you can see, is in itself is an example of a intelligent biomedical signal processing. You must have seen this thing. Okay, that when basically players practice, they used to wear this type of vest. Okay, so what this vest is all about? This vest is, anyone? Can anyone tell me what is this? Okay, this is basically to assess the player capability. Okay, that's what the vest basically does. So it basically contains multiple sensors. Okay, different type of sensors that can measure the muscle movement, their heart rate. Okay, so different biological feature. Okay, this vest can measure. Now what is the benefit? The benefit is that it will help the player or the coach to assess the performance. That, let's say, you in a particular shot you want to move up to, let's say, 30 degree, and you are actually moving up to 35 degree. So it is not giving you the way, it is not basically giving you the angle at which you should play the shot. Okay, so why it is happening? Because of some issue. So how you can rectify? You can basically try to get a feedback through this mechanism. Okay, so this mechanism is going to basically give you an ability to rectify your performance. Okay, and the thing that I am telling you for is not only true for the cricketers or for the sports only. Okay, the same thing is true for any way. Like for example, these days everybody is using this smart watches. Okay, or some sort of tracker. Okay, either in the mobile phone we used to count how many steps we have moved. Okay, how much calorie we have already burned, and what is my set target. Okay, so what we basically try to do, we try to basically remain fit. Okay, that is what the objective is. So it is nothing but the healthcare. So the main objective of all this thing is to have a situation or position where we can say that what type of things we should keep to stay fit. Okay, and what type of things we should exclude from our day-to-day activity that is making me non-healthy. So that's what the objective of this thing is. Okay, now if we see the world from the post-COVID era. Okay, so in the from the post-COVID era, what is happening? That many things in the this biomedical domain or biomedical signal processing or healthcare domain basically changes. Okay, earlier what was, for example, one thing like this is called the home monitoring. Okay, now in the post-COVID era, what happened that now people don't want to meet to each other. No, doctor cannot see the patient, patient cannot visit the dispensaries, because otherwise what will happen? The disease will spread out if it is a communicable disease. Okay, so that's why people now gave more focus that how can we enhance the home monitoring. Okay, in this area also research focused more, because earlier this was not the focus. Or you can say remote monitoring also basically comes from this, got more you can say focus. Okay, earlier it was not that focused. Okay, in addition to that, we have also come to a place where what I want is that the single sensor must have the ability to detect multiple diseases. Okay, what single sensor? Single sensor means, let's say you have to see the how your brain functions. Okay, whether what is your mental health right now, if you want to see that thing. So what is you are going to do? The best thing is to go for the EEG. Okay, few of you must have already seen that thing. Okay, where we basically capture the brain signals and try to see how our brain functions. Okay, that is the EEG. ECG is where you basically see the activity of your heart. Okay, now you have, there is a list of signal, different biomedical signal that basically give you the idea how different organs of human body works. Okay, now what I want, let's say I want to just scan the complete person. Okay, from top to bottom. I have to take all, let's say there are 16 different type of signals that I have to capture. Okay, now that is a problematic thing. Why? Because I have to do the scan 16 times. Now if we can come up with a methodology that only single scan can help you understand all of the things, that will be very good, isn't it? Now let's say you have a tracker, okay, that you have in hand. So right now what type of watches we have? Right now the watches that we have are basically your heart rate it can monitor, your skin temperature it can monitor, or you can say the body temperature it can monitor. So these things you can monitor, but if I ask that same watch to monitor my blood glucose level, it cannot. Okay, but if we can create that type of devices, that will be better. How to create that type of device? Means can the same smart watch we can use to monitor the blood glucose level? Can the same smart watch we can use to monitor your current emotional stage? Can I? For example, right now I am speaking. Okay. Now how many people are listening right now to me? Can I monitor from your watch? If that data is accessible to me, how many of you are listening to me, and many of you are just sitting there and looking at me? Can I? What do you think? Yes, I can. But the only problem is, first thing, I must have access to your data. That is the first thing. And second thing is, that data must have this information into it. Okay. Now I will give you one example. For example, let's say right now I am in a very bad mood. Okay. So if I am in a very bad mood, definitely there will be some physiological changes in my body. For example, just by looking at me, you can tell me that right now, sir, you look very angry. Isn't it? Just by looking at someone, I can tell. How? Because at the face, I can see the expressions. Okay. Now let's say I am in a very bad mood, but I am not showing it through my face. I somehow try to manage it and I am not showing it. But still inside my body, the changes are still there, isn't it? So that change I can monitor with the help of my brain signals. I cannot hide it. For example, the lie detector test. When you are telling a lie, you can manipulate very easily. But when you are on the machine, you cannot hide it. Isn't it? So what is happening? Your brain functions in a different manner. Your heart functions in a different manner when you are telling a lie. So in the same way, when you are in a bad mood, when you are very happy, okay, at that very moment also, these type of changes will be visible. Isn't it? So what is going to happen? These type of changes will affect, and definitely going to affect what? My functioning of my body. Okay. And my body functioning simply means my ECG will change, my EEG will change, and the same changes you can also see in the PPG signals. The signal that presently we are using for your smart watches. Most of our smart watches are based on ECG and PPG, the combination of that. Okay. PPG are basically the photo signals, okay, or optical signals you can say. So it basically goes inside, okay, our body, and depend upon what is my blood flow level, okay, the reflection will change. If I send a signal to some place, if the blood flow is working in a different manner, okay, the reflection will be different, and if it is very dense, reflection will be different. So PPG basically helps us to monitor what? To monitor the blood related changes very easily. For example, blood pressure I can see. For example, oxygen levels we can see very easily. Okay, but there are certain things, definitely certain things that we cannot measure with the help of PPG right now. What is the problem? The problem is that till we haven't developed a technique that can basically capture those changes. Okay. So as I told you, when I am in a bad mood, my EEG changes, my ECG changes, definitely there must be a change in the PPG also. The only issue is I am not able to detect it. So I have to come up with some techniques that can detect those changes. And those techniques are what? Those techniques are nothing but intelligent techniques. Some techniques I have to develop. Okay, that can find out those changes. Okay, so that's what the objective of our future research is, to find that out. Now let's talk about these changes, why they are required. So the very first thing I told that we required basically the sensors, different sensors that can tell you the multiple issues. Okay, so this is the very first research direction where people basically working. So sensors are already there, isn't it? So one possibility is to work on the sensing itself, to develop these type of sensors that can make the monitoring even more effective. Effective in the way one sensor is there and it can do multiple things. It can monitor multiple parameters of my body. So that is the first thing that I want to develop. Second thing is your around the technology part, where we have the mass monitoring, quick action, informed decision. Okay, so what is the informed decision? Informed decision is something where I have multiple parameters with me. Okay, so I have developed a technique where I already got your ECG also, EEG also, different type of signals are already with me, and on the basis of multiple inputs, now I'm making a decision. So that I can call more informed decision. I'm not just considering one parameter, I'm considering multiple parameters. Okay, so that is more informed decision about the situation. Okay, so that is what the thing is. Now if you see this spectrum, okay, in this spectrum itself you can see that wearable devices are not limited to only your health monitoring. So here we have three different sections. One is medical, another one is wellness, and another is sports or fitness. So as you can see, the spectrum is very wide. Okay, so what is the basic difference? Medical means person already have some issue, okay, and I want to monitor it. Wellness is I don't have any issue, I just want to remain fit. The smartwatch basically comes under mainly in the wellness section. Okay. And last is the sports or fitness, means on the basis of what type of feedback I am getting, I just want to enhance my performance. So sports is basically the domain where on the basis of what type of, what is my current strength, if I am able to know, or I am able to know at which area I am not particularly able to perform well. Okay, so somehow I can do better. So the sport shoes comes with the sensors, vest comes with the sensor. These are the things that basically deal in the domain of sports or fitness. So in all the three areas, what we have is a very broad spectrum. Okay, and different type of sensors, as you can see few of them over here. The wireless EEG headset, hearing aid, the vision assistance. Okay, so in certain cases it is actually become a necessity. For example, if somebody is not able to listen, okay, or there is some hearing loss. Many people have the hearing loss. Many people have the error in their vision. Okay, so there must be a mechanism through which we can correct that. Okay, and not only correct that, we can give the feedback also for the future. Okay, so then these type of intelligent devices basically works in a very useful manner. Okay, so now the very next thing is that what is the intelligent biomedical signal processing? If I am using machine learning with biomedical data, is it sufficient enough? Can I call it intelligent? Can I? Okay. So just using machine learning with biomedical signal processing is not sufficient enough. You know that beyond machine learning, we have gone for the deep learning. Then beyond deep learning, we have the In deep learning further, we have segregations where we have the temporal features, we have LSTM models, okay, and what we have this transformers. So a huge set of you can say different algorithms where we have a chain of algorithms are available to me for exploration, okay. But this alone is not intelligence. Intelligence, if let's say you have to define intelligence, what intelligence basically means. So intelligence is the ability that only human have, okay. So intelligence is only defined what if a human can do, if the same thing can be replicated with machines, we can call it intelligent, okay. For example, the parrot can just speak few words, okay, we call it intelligent. It's something very nice behavior that other species doesn't have, okay. So intelligence, whatever human can do. Now human level intelligence is obviously a tough thing to gain, but nowadays what we have is somewhat, you can say, semi-intelligent sort of situation where we have at least intelligence up to the level where even human can also get surprised, okay. Few examples, obviously the chat GPT is there, in which is basically based on the LLM models. Similarly, in the case of this biomedical data also, we do have few examples. For example, let's by looking at the X-ray, I can tell that what type of disease you have. So if let's say I am a medical doctor and I can tell that what type of disease you have, in the same way, let's say machine can also tell that what type of disease you have. So I can call that particular algorithm or that particular machine is nothing less than intelligent, okay. So at least it has some sort of intelligence. But after a level, obviously machine is also going to fail and it is not able to detect it well. If I don't give it sufficiently large amount of data, machine is bound to fail. And the same is true for human also. If human does not have sufficient experience, if you have never gone exposed to a situation or input, and if I give you suddenly a new thing, okay, all of it together, obviously there is a chance that you also get fail. So same is true for the machines also, okay. The situation is pretty much similar. So if we just try to see this intelligence part in the biomedical domain and how this intelligence is changing the biomedical signal processing, okay, that's what we try to basically now see, that what are the top 4 or 5 things where this intelligence really changed the biomedical era. So if we just try to see that thing, so with time what happened, that the machine developed the ability to correlate, okay, and that is a very good thing actually. Now, as I told you that there are different type of signals. These are only like 5 signals I have kept over here. Actually, the list is very long, like more than 20-25 signals around there for the biomedical signal itself. Okay, so here I have just kept the one that you might already have heard of, or if you haven't, if you go to any hospital, you will easily able to get ECG at least. Okay. Heart related this capturing you can easily get, okay. So at least you can see also that how this signal basically works. So what these type of signal basically do, they capture some phenomena, either the brain activity, heart activity, blood pressure changes activity, so some sort of activity that changes in our body, okay, that basically these signals try to capture. When I close my fist, what is going to happen? My EMG is going to change. Okay, muscle signals are going to change. It can get more in amplitude, very simple thing. It can get more in, when I concentrate more, alpha signal is going to enhance in the EEG. Okay, the amplitude, when you do meditation, okay, alpha signal enhances, your attention span enhances. Okay, so these things what we can do, we can also monitor these things, and on the basis of these feedback, we can make the provision to do it in a better manner. For example, let's say you are doing meditation. So what is your aim? Your aim is to attain a stage, okay, where you can see your body actually got very relaxed. That's what your aim is. Now, if somehow I can see how well you are able to do it. No. Let's say I'm the guru of meditation, and if I ask everybody, okay, go ahead and do the meditation. Now, there is no possible way for me to see that who is doing it better, who is not doing it better. It's only you only know how good you are able to do it. Okay, and I don't have any way through which I can tell you that how you should basically make it better. Okay, how can I tell you? Because I don't have any feedback, isn't it? So what can I do? I can give everybody a EEG band. Okay, you have to wear the EEG band, and that data is coming to me. Now that band is now telling me what is your current EEG signals. And on the basis of those signals, I can tell who is doing very good meditation and who are the one who are not doing not that well. Okay, so I can basically make a class that these are very good, these are little less, some are very poor. And then I can know that basically now I have a segregation. Okay, that what you are doing, they can share the experience, that what are the things on the basis of which we are able to do it better, and what are the things why others are not able to do it well. Okay, so once you have this segregation, that is really a good thing. Okay, so we need some sort of mechanism to get this feedback, and that is possible from where? From the signals. Somehow I have to capture that signal. Now what is this correlation? Correlation is when I have one type of signal, and with the help of that signal I can predict another type of signal. Means I have EEG of yours and I can tell what is your ECG will look like. Okay, so this is I can call correlation. What is the benefit? Simple. I need not to measure two signals. I have to measure only one. Now in addition to that also, some signals are really hard to measure. Okay, and hard means money-wise hard. Machine will be costlier. For example, EEG, if you go to measure up to like good resolution, what you need around 30 lakh machine. But if you try to measure the PPG, like hardly within 50,000 you will be able to get very good PPG machine. Okay, so cost wise the problem is everybody cannot afford. Okay, so if machine developed this intelligence, and they basically researchers are working on this domain, that if somehow we able to do the correlation. Okay, so what is the benefit? The benefit is we are going to take the low cost signals. Okay, low cost, not low quality. Okay, so there is a difference between the both. So the aim is that somehow we are able to see or monitor these low cost signals and try to develop a relation with the signals where the monitoring is very costly. So if this correlation can be established, okay, the things can reach to really needy people, okay, where otherwise healthcare are not possible to basically means government has to spend a lot of money to reach to those remote areas. There also we can reach and provide this solution. Okay, so this is first thing. Second thing, as I was already talking about, your ease of monitoring. Okay, ease of monitoring is some signals. For example, let's say you just want to try and find out the glucose level in your body. The very simple example. Glucose level monitoring is one of the toughest thing you can say, because every time if you want a continuous monitoring, what you have to do, you have to prick the finger. Once you prick the finger, then only you will get the blood samples, simplest, and then only you can monitor that what is the particular blood glucose level of the body. Now the problem in this methodology is, let's say somebody have a sugar, okay, and continuous every day, morning, evening, maybe in afternoon also, and you have to like take 3 samples a day. Now, if you're taking 3 samples a day, you can assume what will going to happen to the finger. Every place you have to make a prick. Okay, and that you have to do lifetime. So this in itself is because these type of process are called invasive process, where you have to insert something inside the body to monitor certain things. Now, if the same thing, this monitoring can be done with the help of a non-invasive method. Now, if we can develop a technology, a method, and now people are basically working and try to do it, where we can just any physiological signal I can take, any physiological signal. One of the simplest example could be PPG. Okay, that we, as I told you, in smartwatches you already have PPG. So if you have the PPG, and if I can correlate this PPG with my blood sugar level, if both can be correlated, isn't it will be very good or easy for the person? All you have to do just wear your watch. You wear the watch, and rest tracking will be done with the who will do the tracking? Tracking will be done with the watch itself. You need not to worry, you need not to prick, you need not to every time you have to check. Continuous monitoring is there, isn't it? So that will basically help you. Now the only issue is which signal is the most suitable, where that we have to find out actually which signal is most suitable, in where we have to collect a lot of data first thing. Okay, because it's totally possible, like PPG, as I told you, work on the photo signal reflection. Okay, so photo signal reflection is dependent on your skin color also. For example, right now all the signals that we have in the public domain are basically mostly from the Western countries. So Western countries usually have a white skin, as compared to us we have little brown skin. Okay, and if you go to southern side, we also going to have black people, means skin tone will be there. Okay, so because with tone also this PPG signal reflection going to change. Okay, so that's why if you talk in the context of Indian population, you have to come up with data set that is relevant to the Indian population. So in itself, the very first thing is to collect the data, and once you have the data, then try to make a correlation. And I'm just giving you one example of PPG. The same thing can be extended to many different type of biomedical signals that are easy to collect. Okay, so that is the second thing. Now coming to this data fusion, okay, to feature fusion. Okay, so we have also moving from data fusion to feature fusion. What earlier we used to do, we used to collect the data from various points. Okay, as I already told you earlier also, that EEG is there, ECG is there, PPG is there. We are going to collect everything. And once we collect everything, now we are going to see among this, which feature I should keep, which feature I should discard, or even better, can I combine them all and make a data fusion? So combining them all will actually make my overall model very complex. Like if I give you a smartwatch, along with that there is a headband also, along with that there is a waistband also, along with that there are some different things are there. Different type of devices you have to wear. Like if I give you 10 devices to wear, it will be really problematic for you, isn't it? But if I give you just one device that you have to wear, and that is, let's say, a very simple ring. Nowadays we are moving from smartwatches to smart rings. Okay, so if simple rings are there, one ring you have to wear, and that can monitor all your vital parameters that are really important to monitor. That will be very good, isn't it? So that can be done when we move from data fusion to this feature fusion. So what is feature fusion? Feature fusion means same data I'm going to use, and from the same data I try to find out different features, statistical features, temporal feature, time frequency domain feature. So if we have this spectrum spectrum of features available to me. Every feature tell me about different things. Okay, for example, if you take a signal in the time domain, it will give you what? Amplitude. But if you take the same signal in the frequency domain, what it will give you? It will give you the frequency components. Correct? And beyond that, once you have the frequency components, you can also tell which frequency component appear at which time. Okay, so that you can do if you go for the even further, this, for example, wavelength domain you can call. Okay, so all these features are giving you different information about the same data. So the feature fusion, if you can do, one data can be used for different purposes. Okay, so that in itself is a very good thing. Okay, so that is our third point. Now, further, what we are doing is we are now moving to finding the best feature, to finding why this feature. Okay, that you can call the explainable AI. Okay, so what we try to do over here is we try to see if something is happening, then why it is happening. Okay, one very good example could be that let's say I am eating an apple. Okay, when I eat apple, my blood sugar level changes to, let's say, units, 50 units. But if some other persons eat apple, their blood sugar level is only going to increase by 30. Why so? What is the reason? I just want that insight. Okay. So, because it is not only important to know what is happening, it is also important to know why it is happening. Okay, so for example, this sharp value, as you can see on this, so a few of the parameters or activities, as you can see, our age, heart rate, O2 saturation level. So these levels and these axes is basically, here you can see two axes we have. One is, here you can see these two axes we have. So this basically shows that how much contribution does this feature have. Okay, how much contribution this features is having in positive correlation or in negative correlation. Positive correlation means if I have this feature alone, okay, how it is going to affect my prediction. Okay, so the more you have, that feature become important. Means in this case, as you can see, temperature become really important. No, depend on the fact that what we are doing. Here we are doing whatever we are doing. In that particular case, temperature become very important. Okay. And if it is in the negative direction, it will show that including this feature is impacting negatively on my predictions. Okay. So that it also is a problem. I don't want to include that feature anymore. Okay, because it is affecting my model negatively. So this will help us to get rid of redundant feature also. Okay, as well as this will help us to find out which feature are the most relevant for my model. So both the things are now ready with me. Okay, and that is really a good thing. Why? Because earlier what I was doing, I don't have any insight of my model. I don't have any explainability at all. What I have, I was just taking the inputs, feeding it to my model and try to see how the output changes. And we are just playing around the accuracy that I am getting 95%, you are getting 96%, you are getting 98%. That is what we are doing. Now what we try to do, we try to find out that if this change happened, why it happened. And knowing why it happened will also help me lightweight my overall model. Like if only one feature is important, I will keep that. Let's discard rest of the features. Discarding rest of the features, discarding rest of the signals will be really beneficial. I can make the hardware in a very tiny model. I can make just simple rings. There is no need to make a watch. Even in future, maybe you don't need ring also. It can be so small you can just directly just, it's like a pin, you can just put it in here, something like that we can create. Okay, why? If we can make it very miniature model. Okay, that's what we try to do. Okay, so that is the objective. Now further, what we have in future really is the personalized healthcare, okay, or personalized predictions that we want to do or make. Okay, so overall, if you see what this thing is going to do, is going to give you person to person specific predictions. Okay, the example that I have taken earlier, if you have taken one apple, then this is going to happen. Okay, another person is taking the same apple, different thing is happening, because every person's body is working in a different way. Okay, now I cannot have the same medicine for everybody. Okay, because every medicine is going to behave in a different manner. Now the problem is how to monitor, when you eat the medicine, how to monitor that which particular medicine is going to behave in which manner. So you need a feedback. Biomedical signals could be that feedback. The way it can help you check your vitals, the way it can help you check the meditation concentration. In the same way, it can also help you to monitor or give a prediction with a feedback. Okay, so that will be really good thing. Okay, and because different people are different, so that's why the countermeasures that we are creating, or whatever thing we are supposed to do to counter that effect, is also needed to be design person specific. So it will become personalized now. Everything become personalized. Okay, that is what, that in that area we should basically now work. Okay. Now, for example, one possibility you can think of, actually one of my student already worked on this. So what we try to do, we try to just correlate few of the health parameter with your hazard monitoring. Hazard monitoring means, let's say P2.5 is there. Now, we all are hearing nowadays that in Delhi, in this Mumbai region, Supreme Court is giving you guideline that we don't have any magical stick that we can use to just put it down. Okay, so one possibility in this case could be the monitoring. It is obviously, this is monitoring. This is not a way through which you can basically get rid of this thing. But different people have different effect of pollution. Obviously, it is bad. But let's say my resistance towards the population is somewhat better than you. I mean, I'm not sure. I have to check that. Okay, I'm just telling you one fact, that it may be possible that different people have different resistance. So can I check that? So if I have a smartwatch, or if I have a band or some sort of wearable device that can do both the things, it can take the health monitoring, body temperature, heart rate, then I can include many more ECG, okay, PPG, different type of signals I can have, and there also I can have different type of hazards like CO2 levels, P2.5 levels. What are the different things that we have there? So we can add both type of things, and we can see which particular hazard have the highest effect on my heart rate, on my ECG. So I will try to do this correlation study. I can, okay. And how this is changing from person to person. For me, it might be different. For somebody else, it might be something totally different. So we try to now understand this phenomena also, that how this thing is basically changing person to person. Okay. So now obviously this very thing can be extended to very large possibilities. Okay, where we can have many more parameters. We can include that. Okay, so what are the challenges in this very domain? One is your power versus speed trade-off. Okay, so what is power versus the speed trade-off is, you make any device, any wearable device, any device. Okay, it always requires some power. The more power you give, at a higher speed it can work. But the problem is, because you're making a wearable device, you cannot have an infinite power. Like cannot plug it because you're moving. So you need a battery. Battery have a limited capacity. So what you want? You want it to keep as small as possible, because otherwise the weight will be too much. So power versus speed is something where you can also say that power versus accuracy also, because the more signals you have, the more features you will extract, there is a chance that the accuracy will be better. Good chance. That's what we have seen also in the past literature, that the accuracy tends to get better, okay, with the more power. But the problem is we cannot have an infinite source. So that's why there is always trade-off between these two things, accuracy and your this power requirement. Okay, so that is one challenge area. Now you have a huge amount of data that is coming now. Now everybody have a smartwatch. You must have signed an agreement while you start using it, and in that agreement, most of the companies actually ask you to give your consent to collect the data, and most of you knowingly or unknowingly already ticked that, and company is already collecting your health data. It's a good thing, and in few manner it is a bad also. So now, depending upon what the company actually wants to do with that data, if their intentions are good, it is good. If their intentions are bad, then it is very bad thing also. So now, depending upon that fact, a huge amount of data is coming. Now, if a huge amount of data is coming, you need some way to process. Just giving the data is not sufficient. You need that type of GPU. You need that type of cloud infrastructure. Okay, and you need the efficient algorithms that can basically help you get rid of the redundant feature, redundant data. So those things are now required. Okay, so those are the main things, and in that itself I have told you the ethical concerns, like if I am collecting your data without your consent, or keeping you in a good faith that I am not going to do anything bad with that data, but actually I am. Okay, so that is the ethical issues also that researchers need to take care of, that somebody not be able to take the data in a bad, for obviously bad purposes. Okay, now few of the security issues that we have in this very domain, you can also call them challenges only for the future. So one is this access control. Access control is when basically we made this recording of the data, okay, different levels in our mobile phones, in cloud infrastructure for the companies. Okay, so there is some sort of this access control is required. Who can monitor that data? Okay, only machines can monitor. For example, if you talk about GPT itself, who can see that data? Whatever I'm making, this conversation is going on, who can see? In the WhatsApp, who can see? In the same way, your biomedical data is also very important. You have some issue. Now, if that data is, let's say, accessible to the insurance company, okay, you have, let's say, some heart related issue. So what they are going to do? They are going to increase your premium. So this is not a good thing for a person, isn't it? Having a uniform is a good thing, no, because everybody is covered. Otherwise, it will be a bad thing for the citizen, isn't it? So who can monitor, who can access? That access control technology need to be developed. Then this next thing is the data confidentiality, where we have to, or the persons who have the access, they should not leak that data. So those unauthorized disclosures need to be monitored or created. So these are some, what you can say, the challenge in the cyber security domain, because I heard that you have a CSE in AI ML also. So for that people it might be of interest. Okay, second thing is, let's say we are doing the remote monitoring, okay, and this data integrity, that is really important, because let's say I'm sending the data from one place to another, and in between somebody manipulates that data. Okay, so what is going to happen? Whatever recommendation the doctors are going to give, those recommendations will be on the basis of that manipulated data. Okay, so in between there should not be any breach. Okay, so that is about the security concern that we have. And last is the non-repudiation. Non-repudiation is I have paid for some services, but you are not allowing me to use it. Okay. So why it might be happen that somebody fraud your identity. Okay. So these are basically few of the security concerns that we may have in this domain. Okay. So obviously this is just a brief overview. Okay, because I was allotted 45 minutes, so I tried to keep it brief. So that's it from my side. If you have any questions, query or suggestions, please let me know. Thank you. Yes, yes, please. Yes.
Thank you, sir, for the very insightful talk. The bank officer now from the Department of Artificial Intelligence. My question is that you have mentioned in the app that you are there in the feature inspection that some features will positively affect the prediction and some may affect negatively. So how do some features may negatively affect the prediction? If you can just expand this example. And so my second question is that please tell us what is your specific work in this area? Like this area you have given an overview. So I'm interested in knowing that what specific.
In which area I basically work. Okay. See, the diagram that I shown you. Yes, this was the diagram. So what is the difference? First thing is how it is affecting positively, how it is affecting negatively. For example, I will take a very simple example. Let's say you are supposed to just visually see me. Okay. So this is my face. You are able to recognize. Yeah, this is Dr. Ansari. Now instead of that, what I will do, I will hide my face. Okay. I will hide my face and only my eyes will be open. Only this much. Okay. So this is my eyes. This is one of the feature of my face. Correct. Now in the same way, I have an ear, another feature. I have a nose, another feature. I have hair. I have skin color. I have many things in my face. So all these things are basically features. So everything that is listed over here, is basically feature. Okay, fine. Of my prediction, and on the basis of these features I am going to make a prediction. Now there are certain features in my face that make me very different from, let's say, one more person. One more person A is there, and with that person this particular feature is going to make both very different from each other. Okay, but let's say in this world it may be possible that somebody have a very same eyes as mine. Possible? So if I took the eye as a feature and I leave this temperature, if I took just eye, so what will happen? My model will get confused between me and him. Okay, because that feature is not able to make the distinction now. But only temperature if I take, very good. Okay, so that's how basically this correlation works. With some feature are adding to the prediction accuracy or the beyond baseline, and some features are actually making it poorer because it is a confusing feature, sort of. Okay, so that's how basically this thing works. Now about done na? Yeah.
Sir, we have taken features in place, we have arrival transport and
Actually,
so these are the feature basically.
yes, these are the features depending upon what I am doing. This is a feature of a healthcare setting actually. This is not like biomedical features. This is, let's say, you can call sort of response time of a ambulance. So on that basis it is there, like arrival of an ambulance, arrival of a transport, it is on the basis of that. Let's say you want to see that in particular setting, which particular healthcare unit is working very efficiently. So on that basis it is there. No, it is not for the disease.
What type of prediction we are using?
For let's say you are working on a healthcare unit, like how efficiently or how quick the response time was. for a healthcare unit. On that basis, it is there. But if you are working on any disease, then the features will be different. For example, you are doing the face recognition, then the features will be totally different. This is just an example image. This is not my image. I have taken it from somewhere just to explain it to you. Yeah. Okay. And regarding the second question, in which area I basically work works in the ECG domain, ECG based emotion recognition, and PPG domain. Okay, where we basically try to explore the mental load. Like, let's say you are in a department working, okay, and continuous, I want to monitor how much mental load you have, okay, while you are teaching, while you're doing the administrative work, when you are sitting over here, so how much load you are in right now, okay, and that is beneficial for your you can say administration to know that what type of things they can do or come up with to make the things better for you, for your life. Okay, that's what we are working on. Okay. Yes. Anybody else? Yes, please. For getting the data. Yes, there is one website, PhysioNet is there. PhysioNet. For the biomedical data. So almost, but the only problem is that on PhysioNet you will mostly find the data from the Western countries. That is the only problem. But yeah, the data is reliable because on that data, definitely good amount of work has already been done, and new data also kept on coming. So either the hospitals are there or some universities are there who have a tie-up with the hospital otherwise. So they only upload the data. So like you can say in a month at least 2-3 data sets, new data sets will arrive there. So you have the possibility, like if you are the first one, it will be easier for you to get that work published. Okay. Yeah. Yes. That's it. Okay. Thank you very much. Thank you.
Thank you, sir. As a gesture of respect and gratitude, may I request our respected Director Academics, Professor Dr. Vishal Nagar, sir, to kindly present a memento to our esteemed keynote speaker. Thank you very much, sir. Now, I would like to request to all the esteemed guests to proceed for the high tea, and the next session will begin at 8:30 a.m.
review publications, come up with chapters and monographs. And serving on editorial boards if the members to develop chapters regard the distribution of cognitive and opinions and serving on editorial boards of leading IEEE and PSITKanpur journals. Comma Professor Sukla's contributions. पहले विशाल में जैसे वो मुख्य मूवमेंट को स्कूल के वालों के कांग्रेस को थैंक यू तो बोलोगे वो एज ए जूनियर करते हैं एक थैंक यू स्टूडेंट है थैंक यू एक लाइन को उनको स्पीच का दो का ज़्यादा वो स्पीच दिया है तो उनको ट्रीट तो करोगे थैंक यू से
कोई फ्रेंड है?
मेरी तो है फ्रेंड, अगर मैं रिक्वेस्ट करूँ तो हो सकता है आ जाएगा।
हाँ तो हौसला से बोलो, क्योंकि हौसला मेरी जो फ्रेंड है वो बाहर गई है, मैंने उसको मैसेज करा था, तो मैं ब्लेजर के लिए बोला तो मैंने उसको मैसेज करा था।
किसी के पास एक से लाना लाइन
Welcome back, everyone. We hope you had a refreshing and a fruitful time networking with everyone. When the brilliant minds interact, innovation becomes inevitable. This energy in this hall is truly inspiring as we now deep dive here in the core essence of EACE 2025. Now the time marks the beginning of action-packed sessions. So we are here with our respected keynote speaker, Professor Sandeep Shukla sir, Director IIIT Hyderabad. Professor Sandeep Shukla sir received his PhD degree in the field of theoretical analysis, complexity analysis, and mapping of algorithmic aspects of formal verification. After his PhD, he worked in a telecommunication network management software lab where he developed distributed algorithms and their implementations for network management systems and did research on implementations for network management and on research on middleware based distributed object technology. However, after 2 years in the telecom industry, he went back to his roots and joined the formal verification team at Intel. Working on the roots after joining the verification team, formal property verification of the Itanium processor, microarchitecture, and while being at Intel, he took up the interest in the high-level system modeling languages, simulation, and high-level behavioral synthesis. He was in the pilot team of experts for looking into various possible system design languages for generation IA64 processor design team. Eventually, he became a part of an IA64 platform architecture group where he had formally specified IA64 protocols and automatically generate checkers, etc. In 2001, after 4 years of industry exposure, he decided to go back to academia. So he joined a postdoctoral research associate position at the Center for Embedded Computer Systems at University of California. There he started working on the dynamic system, level power management, IP composition for SOC design, formal embedded system design. In fall 2022, he joined Virginia Polytechnic and State University as an assistant professor of computer engineering. His research lab is called FERMIT, Formal Engineering Research Models, Abstractions and Transformations, whose websites provide more details. He is globally acknowledgeable expert, authoring 300 plus peer-reviewed publications, book chapters, and monographs, and serving on editorial boards of leading IEEE and ACM journals. Professor Shukla's contribution to secure system and embedded system designs are huge. So please give a big round of applause for Sir and introduce him on the stage.
All right, can you hear me well? Hello?
Yes, sir.
Are you able to hear me?
Yes, sir, you are audible.
Okay, thank you so much. So good afternoon, everybody, and I'm sorry that I am not there in Kanpur. I have moved from Kanpur to Hyderabad, so I am making this presentation online. The topic I want to highlight is security of AI-based systems. Now that everybody is using AI, Gen AI, agentic AI, and people are talking about getting a lot of the work done, including software coding, software engineering, testing, as well as many other workflows in the enterprise organizational activities. We have to worry about the attack surface that gets exposed by such pervasive use of AI-based systems. The other issue that is bothering people is that we also are seeing AI being used by cyber attackers, threat actors, against standard systems, including AI-based systems or traditional enterprise systems. And we recently saw an attack that was attributed to Chinese threat actors on 30 different companies by using Anthropic's Claude code generator by 90% agentic AI. So 90% of the work that a hacker would have done was done by agentic AI in these attacks. So we have seen both AI-based systems being attacked by hackers because of various weaknesses that those systems might have, but we are also seeing AI being used for attacking systems. So we have to worry about both, and I want to point out some of these issues in this talk. So what we are seeing is that large scale deployment and a lot of promises about AI, agentic AI, etc. Now the question is that while we are using them, the hackers are also well positioned to use them, because many of these things are easily available. Either you have to purchase API access to OpenAI or API access to the Google, say Anthropic or something, or you can also download your own local LLMs, pre-trained LLMs. Then you can actually, if you have if sufficient compute power, you can actually run them locally. So you have a lot of AI-based systems that can be easily exploited by hackers. So we have to now start worrying about, not only we have to worry about protecting our systems against hackers, we have to also worry about protecting our systems against AI. So that's the one thing. The second thing is that the AI systems that we are designing and deploying, they also have a lot of attack surfaces, and we have to worry about how to protect those as well. So both are the issues that we need to consider. So in this talk, I'm going to talk about some of the use cases that people are deploying AI for, generative AI, and then understand what are the emerging threats in these towards these. Also, identify some recommendations. So there are regulators, there are scientific bodies, as well as there are legal legislative processes through which number of different recommendations, number of different requirements have come up about secure AI practices. So we will discuss some of that, and then we'll have a little bit of discussion at the end. So what is happening with generative AI? So all of you probably have used ChatGPT, you have used Gemini or Microsoft Copilot, etc. So you have seen that you can make a natural language query, and then you can generate text, you can generate code, you can generate image, audio, video, depending on what the particular Gen AI system is trained to do. Now, usually Gen AI is about content generation, because they are basically transformers whose job is to actually predict with high probability the next tokens or next set of things, and that's how they work. So there is no inbuilt intelligence in them, but you can actually mimic some of the intelligence by chaining a number of steps. You can mimic, various types of reasonings, but so far the reasonings are rather limited. So you can think of Gen AI as more of a content generator. Agentic AI, on the other hand, is a little more, it's actually a utilization of generative AI. So it has the ability to do some planning, some kind of, it can also call various tools through their APIs. It has certain protocols like MCP, etc. It also can observe the outputs generated by one LLM and then use that or modify that as input to another LLM, and through these iterative steps it can maybe improve some of the contents that one can generate in one shot, or so it allows you to do various multi-step execution. So mostly generative AI is used as core of many of the agents. Some of the agents actually are rather algorithmic, some of the agents are LLM based, and these agents are connected to each other. So if you look at this is a typical agentic AI architecture. It is I have taken it from a very specific application, but just to illustrate what this agentic AI normally looks like. So as you can see that there is this core part that does the planning. Then based on the plan, it can do actions, and then it can do certain function calling. So it has access through MCP or other protocols, API calls, or various other tool calls that it can actually do the call various tools. And then it also can use some kind of a memory, that kind of like a cache, where since the context is very important in LLMs, that is the remembering in what context a particular prompt is being given to the LLM, the answers will be different. Now LLMs have very limited window, prompt to the token window. So therefore many times what we do is that we actually summarize the context into some kind of a memory that is, you might have heard of RAG, or retrieval augmented generation, or cache augmented generation, memory augmented generation, various kinds of. So it's kind of thought of as a little bit of a context memory, and then you can call the LLMs for actual, little bit of content generation, and then you can continuously call this LLM or multiple LLMs to actually make improvement of the content along with additional context and so on. So, but those of you who are a little bit aware of cybersecurity, you can imagine that here there are multiple places where we have connections, right? So we have this agent, let's say, which is connecting to the memory, it is connecting to the tools, it is connecting to the LLM, and everywhere, if we do not protect these channels through which these connections are happening, we are having the possibility of injection of bad inputs. So if it can intercept the inputs here or outputs here, and actually inject malicious content, and that malicious content will then actually generate malicious output or unwanted outputs, and the process can actually become a little bit uncontrollable because this is going in a loop. Similarly, this memory that you are keeping for context may also have injection of wrong information here, and therefore you can also have wrong context and have wrong output. So there are many ways. You can see by looking at this architecture, you can imagine various ways things can go wrong here unless you are very careful. Now, a lot of people now are in a hurry to actually show that their system works, and they have this agentic architecture through which they have automated their entire customer handling workflow, or they're even nowadays they are using these things for mimicking research activities, mimicking various kinds of travel ticket handling activities and so on. And if you are not careful and if you are in a hurry to design these systems and not taking care of this attack surfaces or identify the various attack surfaces, then you are going to get into trouble. So now let's see where are people positioning this agentic and Gen AI components. So people are now saying that, okay, we can do a lot of the operations that used to happen manually can actually be done by automating the internal workflows, ticket management, ticket triage, configuration drafting, and so on. Customer engagement, this is actually one of the major areas where we are seeing agentic AI being used. Personalized virtual assistants, multilingual support, 24/7 self-service, and so on. Fraud and anomaly detection. So detecting, on anomalies in large-scale streaming information, such as transaction information, transaction data, or log data, etc., this kind of stuff. And then also compliance and policy review. So we are seeing a lot of use of agentic AI to see that whether your organizational policy is compliant with, say, a standard, let's say RBI guidelines or SEBI guidelines or ISO 27007 standard, etc. So we are seeing that kind of stuff. So let's now look at the threats, right? First of all of you know that it's actually always on the news that all these LLMs are actually has a tendency to hallucinate. They often generate content that is totally incorrect, totally hallucinated, and it has been shown theoretically that this hallucination cannot be removed. So hallucination is a byproduct of the way the transformers work. So therefore, it is to be understood that when you are generating content using things like ChatGPT, you have to always verify that the content is trustworthy. And we have seen cases, for example, Coinbase, which is one of the exchanges, crypto exchanges, they had a fine-tuned model of GPT that they had allowed customers to query about which tokens to buy for investment, and they got wrong investment advice and they actually had losses. Similarly, you can have you might have read news about Gemini or ChatGPT. They argue, they go see the transformers by themselves do not argue, but if you create these contextual scenarios where they start on showing high confidence, give you misinformation and so on. So we have seen parents, actually at least 7 parents have sued OpenAI because ChatGPT has apparently led their children to commit suicide because of people gave a kind of a sense. The ChatGPT is designed, the wrapper around GPT itself is not a conversational agent, but the wrapper around it that we see as ChatGPT has some people actually assign anthropomorphic sense and feel that they are speaking to a person, and then that's when mistakes happen. So these are some of the societal risks that we have to worry about, financial societal risk. But we also are seeing that people are using, Gen AI, agentic AI to generate deep fake. Deep fake is basically a fake video, fake audio, fake photographs. You might have seen that nano banana that Google has come up with. They have actually are creating this pictures of all the founders of the tech, the tech brothers, what they call, like the CEOs of Facebook and Google, and everybody is laughing it out and all that kind of pictures. They look absolutely real. And because they look so real, you will, in the future, it will be very difficult to distinguish truth from fiction, truth from imagination. So that this is going to be a societal problem very soon. Already we are victimized by many fake news and fake information, disinformation campaign, especially when foreign governments actually orchestrate fake information campaign during another country's election or other volatile situations and so on. But we are also seeing phishing emails, for example, nowadays are much more believable, much more personalized for people, and they are impeccably written. Earlier, we used to know that something is a phishing message or phishing email by looking at the grammar or looking at the implausibility of the offer and etc. But now they actually can do various things, with that. So then deepfake fraud, we have seen that, people have used deepfake video with the same voice as the CEO of the company. And then they actually use this to ask the CFO to transfer large amount of money. And it has happened. People have lost money by being fooled by deepfake fraud. We also see that the data on which these systems are trained or fine-tuned or retrained, this data, if this data is wrong, if the data has mistakes or data has bias or any kind of unfairness, then the behavior of this AI will also be accordingly, because the data is your model is as good as your data. So data poisoning is another place where attack happens. The data that they are crawling and trying to do this is not going to be actually any good, because if it is poison. So similarly, AI assisted malware creation. People are actually creating malware. My students have created malware that were not detectable by any of the antivirus engines in the market, but they were actually quite virulent malware. So this is another thing, and misinformation, etc. So these are some of the major threats that are created by GenAI. Now, GenAI by itself, as I said before, is that while GenAI is being used to do various kinds of attacks and cyber crimes, GenAI itself is being subject to various kinds of attacks. For example, as I said, that there are when you are actually, if you remember this picture, eventually we are crafting a prompt automatically to ask a question to LLM and get answer, and then use that answer to further refine our next prompt and so on, right? So prompt injection, if I inject additional information here or replace the prompt this guy's generated by a man-in-the-middle attack, then I'll completely change the behavior of this entire thing. So prompt injection is one of the major problem that we are seeing, and we are going to see more and more of that. Also, many of these Gen AI systems that are like ChatGPT, etc., they have filters. So they have prompt filters. So they actually, if you ask them to, ask how to create a bomb or something, they are not going to answer. They're going to say that I'm not going to answer because I have been prohibited to answer them. Or so there are various kinds of ways to filter the inputs or filter the outputs so that it's not being misused. But these safety, what we call these safety guards or guardrails, are easy to bypass for most cases. So in 2022, my students actually saw that it was very easy to bypass these guardrails for both GPT as well as Gemini, and we generated a lot of exploits, mimicking the various kinds of MITRE attack patterns. But as later on in 25, when we tried, it was much more difficult. So they have improved their guardrails, but it is not impossible. But bigger thing is that if you have a local, locally run LLM, such as Mistral or something, which a Llama that you have downloaded, it may actually have no guardrail or have minimal guardrail, and it is very easy to break those guardrails. So prompt injection can actually make things happen. Really, bad things can happen. For example, one conference, it was found that people were putting in their PDF file the prompts saying that if somebody is trying to get a review of this paper on GenAI, then give it a good review. And that prompt was invisible. It was not to be printed, but it was there in the PDF. So when the PDF is fed into Gemini or something, it would get that prompt and then it will give a good review. So these are the kind of things can happen through prompt injection unless the LLM has a proper filtering mechanism for this. Now, filtering is hard because you do not know what are the different ways people will do this. For example, people are also using base 64 encoding to do the prompt injection. So if you do not have that, if you haven't thought of that threat model, if you didn't think that somebody will do that, you didn't put a guardrail against that. So this is difficult. The other thing is model inversion attack. Many times these models are trained for billions of dollars with lots of efforts, lots of data that has been crawled through the web, and Anthropic, for example, bought a lot of data. Now, suppose you want to, and then the reason why they are running a black box model is because they don't want to share the model's weights. These models actually are neural networks with billions of weights at various connections. Now, the closed weight models are basically depending. They are making money because their weights are unknown. Now, somebody might actually have enough query on a model to actually do model inversion, although many of these GenAI systems have 7 billion parameters, or even nowadays people are talking about hundreds of billion parameters. Those are difficult to do model inversion. The other thing is supply chain attacks, right? So when you are going to depend on a third-party GenAI tools, pre-trained models, you're downloading Llama, you're downloading Mistral or something. If the source from where you are downloading these things like Hugging Face and all, they get attacked and they get compromised, then you will probably get a malicious GenAI model running on your own system, which is going to compromise your system. Also, people have shown that through prompt injection, you can actually, while you are running a LLM on your own machine, and you are uploading some file that you have received from somewhere, through prompt injection, one can actually attack your own system because the prompts basically are there in that file that you are uploading onto a GenAI system and so on. So very quickly, I want to mention this work of my students who actually showed that they can generate pretty potent malware by just giving prompt about what should be the behavior of the malware, and basically testing the malware through another agent, and then making sure that the malware has the requisite property, etc. So this is an agentic AI system. This is a work that was done by my student Bikash, and it is actually I think available on archive, so you can take a look at that. So they found that out of 10 malware they generated, these are the ATT-CK techniques that these malwares actually have. These malwares have these behaviors, but they found that 5 of the malware out of 10 virus total, which runs about 70 antivirus on any sample you upload. So they uploaded all the generated malware. They found that 50% could not be detected as malware, even though they had all these different malicious behavior. They had 4 of them they could correctly label, and then 1 they gave a wrong label, but that at least they detected it as a malware. So what this experiment shows is that attackers are now going to use these things to actually generate malware that even none of the current antivirus engines are aware of. this is another work my student Nanda and team, Sai Charan and team from NYU have done. Here, what they wanted to show is that when you have captured the flag contexts, normally, it's a manual process by which you actually you are given as a challenge, you are given a cloud-based or virtual machine-based system which has multiple vulnerabilities, and you have to find those vulnerabilities and if exploit those vulnerabilities to actually find some flag. Flag means some data and then you have to submit that data as a proof that you have found the flag. So they actually said, okay, can agentic AI do this without human intervention? So Decipher is one of their multi-agent system that they have done. And in this Decipher, they got about 25% efficacy. That is, it could solve about 1/4 of the problems of a standard CTF that was organized by NYU. They improved this Kraken into Kraken that has better, it has more knowledge-based execution. It had actually had a RAG-based system, and this one did better. And this one actually is going to be published in AAAI conference this year. So what those two examples show is that if the CTF can be done by agentic AI, then attacks can be done by agentic AI, because CTF is basically mimicking attack. It's a rate teaming activity. Now, last week we got a new report from white paper from Anthropic AI. They have the Claude code generation. And somebody purchased API for their Claude code generation and used this repeatedly to actually generate payloads for attacking systems and data exfiltration. And they found that the 30 different companies were attacked by this, and they reconstructed the entire process, and they concluded that this entire process, 80 to 90% of the process was completely agentic. It was no human intervention. So they have now blocked those API keys and so on, so that the threat actor that was using Claude could not use Claude anymore, but they can download Mistral or Llama, Olama or Grok or something, and they can continue. Maybe they are not, these systems may not be as good in code generation as Claude, but at least they can do some of these things also. So we can expect that a lot of these attacks will happen, which is going to be completely automated. But also, we can also use this to do our own red teaming. That is, to check our own system, that our system can withstand attacks. We can actually also use agentic AI systems to continuously try various attacks on our own system to test our system. So until now, we used to do this red teaming, where our own red teaming engineers used to attack the system to actually check the resilience of the system. But if we can automate this entire thing, then it can be done more regularly and more, 24/7. So you can actually see whether your system can withstand various kinds of attacks. So there are two sides of the same thing. One is attackers will use it, so we have to worry about that. But we also have to know that we can continuously test our own system's limits by automating this. So both are there. Now the other thing that we are worried about in use of agentic AI, especially for things like medical usage or usage in case of any kind of decision making, such as if the banks start using agentic AI to decide whether they should give you a loan, or whether the jail authorities decide whether to give you a parole in case a person needs a parole based on their some data that they feed into the agentic AI. Then the one has to be very careful, because these are decisions that are affecting people's lives or people's career or people's future. if the school starts using agentic AI to decide admissions kind of thing, then one has to be careful, because the data on which you train your model, that injects bias and unfairness oftentimes. We have seen this many times. Plus, many times these decisions are often at a 50-60% accuracy. If 50% accuracy is as good as tossing a coin, because when you toss a coin, you will get 50-50. So if you decide something based on coin toss, that is a 50% accuracy. So if the agentic AI, after doing all that work, all the training, etc., if it gives you 50% accuracy, it's no good, right? So same thing, one has to worry about this decision making that affects human lives or human health or human finance or human future career, etc. One has to be very careful about using agentic AI, and that is where all the regulators, such as SEBI in India or RBI or European Union, they are all talking about. First thing is that try to get explainable AI. So explainability is important for such decision making, so that you can explain why you are saying no or yes to somebody for various things. Second thing that you have to do is that you have to be very sure that your model has no bias or unfairness crept into it, because of the data itself is actually on which it is trained is actually biased data. So that kind of stuff you have to worry about. So therefore, people are talking about risk of using AI models, and the risk is not in the AI model itself. The risk is on the application where you are applying the AI. Suppose you are doing the AI to generate, using the AI to generate fun videos. There is no risk, right? Really, I mean, you can generate the video, you can delete them. Nobody is going to become affected by it. But suppose you are using agentic AI, Gen AI, to make decisions on admission of students in a school or something, then that's a high risk decision, because it is going to affect a lot of people. Similarly, if you are going to give loans and you are using AI to make the decision, then that's a high risk decision. Or you are using AI to decide whether somebody has a particular disease by looking at, let's say, his X-rays and MRIs, etc. Without consulting a doctor, you are making AI make the decision. That's a very risky thing. So what this framework says that you have to have a governance mechanism in your organization. If you are using AI, governance mechanism means that deciding when to use AI and when not to use AI. And if you are going to use AI, only use the AI as an aid or a tool, but there has to be a human who is actually making the decision. So the decision can be overridden by a human by applying his own expertise. So if you are using a medical advice based on AI, you cannot by this risk framework, if you are going to use the AI to make the decision and have that as the final decision, then you are making a very high risk action, and you are going to suffer, because in case this is a wrong decision and the person sues your company, or the person dies or gets highly affected, then you are going to basically have a huge impact, and therefore the risk is very high. So therefore you have to first figure out in what context you are using AI, what is the risk of measure the risk of doing that, and this risk, and then manage the risk by having a human in the loop, having explainability, and so make sure that the AI is trained on the correct data, not on wrong data. All these things will be part of your risk management framework. So that is the Institute of Standards and Technology of US, their risk management framework. The other thing that we are telling people is that make sure before you use the AI, you do a proper red teaming of the AI itself, so that you know that traditional ways of the standard ways of attacking, like prompt injections and various other kinds of ways of injecting into the RAG or injecting wrong data, etc. All these things can be are difficult to do. They may not be impossible to do, but at least make it as difficult as possible. How do you know that you have done all that? You have to do a red teaming. You have to, once you deploy your AI system, before you actually put it into real world use, you have to do red teaming. And for this, MITRE has come up with this Atlas framework, which is similar to the AT3 and CK framework, attack framework of Atlas. So you see that they have defined tactics. So these are the tactics an attacker would have used to attack an AI-based system. And then these are the techniques within that tactic that may be used to implement that tactic. So you have to study this Atlas framework and you have to do that accordingly. You have to do the red teaming based on this Atlas framework. The other issue is privacy leakage. So when you are using APIs for ChatGPT, Gemini, etc., you're uploading your files, you're uploading your code to get debugging of the code and so on. You are basically all that data is going to the server of OpenAI or Google or whoever, Anthropic, whoever is actually behind that API, who is actually running the model. Now, they might not do anything with your data, but you cannot tell. Second thing is that the data that they're keeping may not be secure enough. There may be attacks on their systems, and that data may get leaked. So if you're uploading any kind of data that is personally identifiable data, that is very critical data for your organization, you are going to have a risk of data leakage. And that's why many organizations are basically creating their own local running of on-premise, versions of Llama or other things which are open source, because the Gemini or open ChatGPT, etc., are running on the servers of those companies. So there is a big risk. Samsung actually had this problem early on. Their employees actually uploaded some code that was not supposed to be leaked and so on. So that is one issue. Now we have the DPDP Act, the Personal Data Protection Act in India. It has been notified, and every company has to actually be compliant within the next 18 months, which means that if you are using any kind of AI for your organizational work, do not upload any kind of personally identifiable data on the third-party servers, because you are then going to violate the DPDP Act. Second thing is that if you have collected the personally identifiable data for some purpose, and then you are trying to use that data for other training purpose, etc., you cannot do that, because that's another thing is that DPDP Act, that it has to be purpose bound. So RBI has done a very early take on this among all the other central banks in the world. RBI, the Reserve Bank of India, which is the regulator for banks and financial sector in India, they have made a very important decision that they will actually guide their regulated entities, banks and so on. So they have said that if you are going to use AI for any kind of decision making, there has to be a human in the loop. There cannot be a fully automated use of AI. Responsibility cannot be delegated to machines. So there has to be a human who is accountable for every decision. So you cannot say that, oh, AI told me this, that's why I made that decision. You have to apply your mind to actually make every decision, even if you use the AI for help. Similarly, you have to do the model audit and governance, because if the models often have other problems, like for example, models get drift, the data, the patterns drift, and therefore the model becomes useless, or their model becomes risky. So, and then they are saying that the explainable, interpretable, auditable, etc., has to be there. So now when we are advising somebody when they are about developing secure AI systems for their organization, we emphasize certain things. So I will quickly go through them. So secure data collection. So the data is very important. Your model is as good as your data. If your data has bias, if your data has mistakes, or data is false, then your model is going to be really doing wrong things. So this is one important thing. Then you have to train the model in a secure environment so that there is no data poisoning and other things that can happen. Then you have to do rigorous validation and red teaming. That's what we talked about, the MITRE ATLAS framework. Then you have to do secure deployment and access control. So when you are securing deploying the code, deploying the thing, access control is very important. Remember, I said that Anthropic Claude was being accessed by Chinese threat actors to generate attacks. So they eventually realized it by looking at the logs of what was going on and analyzing the logs, and then they decided to block those API keys. So those users cannot be using this. But that is what it is. Then operation and monitoring. So you have to continue to monitor the for various manipulations, RAG entry injection, prompt obfuscation, etc. Like people using various encoding of bad prompts and so on. When you update your model, even if you have a locally deployed model, you have to make sure that you are getting the update from a secure thing. You check the digital signature. You make sure that the model is actually safe. There could be also data injection in serialization, deserialization process, so that has to be also looked at. Incident response planning. Suppose your AI system gets attacked. How are you going to respond? So you have to have a proper plan for that, and that plan has to be drilled so that you know what to do. Especially if you have a lot of workflow automation through AI, then your whole business process may be very much dependent on AI. So AI system compromise means your business process, your entire business is at risk. So you have to worry about that. And continuous governance and risk review has to be done. So applying AI system or deploying AI system for your business requires all these steps that I am talking about. I think I'm running out of time, so I'm going to skip a few slides. And I'm going to mention a few more things. There is also one more thing that you have to worry about is when you are going for purchasing AI-based systems, there are companies nowadays which are also doing what is called AI washing. AI washing means that they claim that they are doing AI, but actually they are not using AI, they are using traditional method. There was a company that raised billions of dollars in the US, Indian company, claiming that they are generating AI code by AI, but actually they were having human programmers in India to actually write the code. So after a while they got, so people who invested in that company lost their money because they actually were defrauding the investors by saying that there is AI behind their product. Similarly, there were 10, so several companies that US Security Exchange Commission has found that are actually found to be doing AI washing. So one has to be careful. Now RBI has done this committee called FREE committee. This FREE stands for Fairness, Robustness, Explainability, and Efficiency in AI. So you should read if you're interested in AI security, proper usage of AI in today's businesses and processes, then you should read this free AI report. This is interesting. But main focus there is that fairness, explainability, and human in the loop. The transparency and also the accountability should be with the human. SEBI also has done similar things. EU, the European Union AI Act, also is very similar. So they also talk about transparency, human oversight, risk management, and quality training data. These are very, very important for this. And then Singapore Monetary Authority also has talked about risk governance for use of AI in financial matters. So the recommendation is that AI risk is high because AI can be attacked. AI systems can be attacked, plus AI systems may make wrong decisions because of hallucination, because of the data quality on which they have been trained, and the way that they have been deployed. They may actually be subject to cyber manipulation. So if we consider all this, there are huge risk of using AI for various decision making process in your business decision making. So therefore, you have to classify your application of AI into high risk, medium risk, low risk, etc. And based on that, you have to do additional measures to actually make sure that you are not creating high risk for your business by using AI. Second is that you have to also document the fairness matrices. You have to also have accountability, who is responsible for the AI outcomes. And audit trails is very important, like Anthropic Claude could find that they are being used for cyber attack by actually doing auditing of their logs. So logging and periodic review of the model behavior, use of explainability standards for when you build your model, continuous risk evaluation. There is also model degradation. A model may often degrade in quality because of the change in the environment in which model is operating. The data on which it was trained may not be relevant data anymore because the world outside has changed. So one has to do that. Bias reemergence, this is another issue. And then exploitable vulnerabilities. This is the other problem, because eventually these models are also software. So they have vulnerabilities. Data handling, secure data handling, and clear human fallback procedures. So this is very important. And then secure model training pipeline, data encryption and minimization, human in the loop fallback plans. These are important things. So in conclusion, Gen AI is going to redefine a lot of domains, but the risks are pretty high, especially if you are using it for your automation of your business, automation of decision making, and if the high risk decision making. So you need to balance the innovation versus responsible deployment, especially in medical, financial, and other decision making. So whenever you're using AI, you cannot stop using AI. Strong governance, clear regulations, and strong technical safeguards are required. Transparency and explainability is non-negotiable, and future depends on trustworthy AI. So that's where I will stop. And if there is time, I can take a few questions.
Thank you, sir, for gracing the conference with your expertise. Now, any questions from the audience? Any questions from the audience? Thank you, sir.
Hello, am I audible, sir?
Yes, you are.
Yeah, very good afternoon, sir. This is Madhuri Gupta, Assistant Professor, CSC Department. Sir, may I ask one question, that how do we measure when autonomy become dangerous?
How do we
measure when
measure?
autonomy become dangerous?
No, so I think that autonomy will become dangerous if you are using autonomy for making decisions that affects human lives or human future career or any kind of human condition. So for example, if you are making medical decisions without a doctor's intervention through automation, or if you are using a decision that will affect a student's future, for example, admission decisions, or if you are going to use AI for making decision on, let's say, giving out loans. So you have to categorize the actions for which the autonomy is being used, and whether that is a high risk activity. High risk, and the risk is defined by the impact that a wrong decision would have. And if you are going to make that decision without a human intervention, expert intervention, then you are going to make you are certainly going to make mistakes once in a while, because we know that none of these models are 100% accurate. And that's why we have to be that's why all the if you look at EU Act, or if you look at the RBI, SEBI, or Singapore Authority, they're all talking about the same thing, that categorize the application, not the technology. Technology can give you automation, fine, but the activity for which you are deploying this autonomy, that activity that has to be categorized as high risk, medium risk, low risk, etc. And if it is high risk, you have to have human in the loop. Without human sign off, do not make that decision as a decision. So that's what this thing is saying. You cannot measure it without actually knowing where you are applying this. If you know where you are applying this, you have to then consider whether it will affect a lot of people, and then accordingly you make the decision.
Okay, thank you so much, sir.
Any other questions?
Good afternoon, sir. This is Dr. Sana from the Department of Artificial Intelligence, PSIT. So my question is that can we merge explainable AI with generative AI, and is there any example existing of this merge?
No, so what do you want to merge? Gen AI?
Generative AI with explainable AI.
Generative AI and what?
Explainable AI, XAI. XAI, sir.
XAI, you mean explainable AI?
Yeah.
Yeah. So I think that this is one area where we are still not doing very well. If you look at ChatGPT or Gemini, they don't have any explainability. But if you are going to use AI for very high risk decisions, as RBI, SEBI, etc. are saying, that unless you have explainable, don't use it for decision making, or at least don't use it for making the final decision. You may use it as a tool to guide you as a first cut decision, but before you deliver a decision, it has to be explainable. You cannot say that I am not admitting your son to my college because AI told me so, but I am not telling you where he is lacking, right? Or I'm not going to deny you a loan without telling you where I am lacking in my application. So unless there is explainability, do not use for high risk decisions. That is what they're saying. So therefore, we have to. People are working on this explainable AI. Hopefully, in the future we'll have better explainability coming out. But right now, we do not have a whole lot of explainability in LLMs.
Yeah. Thank you, sir.
Thank you, sir, for enlightening us today by your thought-provoking and insightful words. Thank you, sir.
Thank you so much for inviting me, and have a good conference. Thank you.
Thank you, sir. Before proceeding further, as a gesture of request of gratitude, I request Director Academics Professor Vishal Nagar sir to present the sapling to Professor Kanadre sir. It is an honor to introduce Dr. Kanedre Sir, our esteemed keynote speaker. Sir is the director of Amity Cognitive Computing and Brain Informative Center and a professor and head of physics at the Amity School of Applied Sciences, Amity University, Rajasthan, Jaipur, India. He has obtained MSc and PhD degrees in physics respectively from Calcutta University and Jawadhpur University, West Bengal, India. In academic year spanning over 30 years, he has published and presented research papers in several national and international journals and conferences in India and abroad. His research areas of interest include cognitive communication, electromagnetic field theory, antenna and wave propagation, microwave, computational biology, and applied physics. He has guided 10 plus PhD scholars in various interdisciplinary fields. He has served as an editor of various Spinger book series. He was an associate editor of the Journal of Integrative Neuroscience published by iOS Press, Netherlands. He has traveled to Netherlands, Turkey, China, Russia, Portugal, Finland, Belgium, South Africa, Japan, Malaysia, Thailand, Singapore, Uzbekistan, etc. on different academic missions. He has established an MOU between Amity University, Rajasthan and the University of Montreal, Canada for various joint research activities. He is an associate researcher of Forward Lab and a visiting professor to Calcutta University and IIM Ranchi. He organizes international conference series such as TEE and TEHI as journal chair. He is a senior manager IEEE and was an IEEE Executive Committee member of Rajasthan. We are truly privileged to have you, sir, with us. Kindly join me on the stage.
First of all, thank you for this nice introduction. I would like to thank the organizers to invite me here, Professor Manmohan Shukla, Professor Raghavendra Singh, Professor Bishal Nagar, who had been instrumental for this conference, Dr. Shailendra Singh. So we were discussing about this conference long ago, and now it has materialized. This is the first edition of EACE-2025. Okay, so before, okay, fine. Let me check. Oh, this little bit tilted is okay. You can see. Okay. So, I'm basically from physics and doing interdisciplinary applications of physics, so to say, and my research training was in theoretical physics, nuclear and so-called high energy, medium energy physics. Then I have been doing the electronics and communication part, antennas, microwaves. I was very much interested in the mathematical cognition, right from my PhD days. And that time, the way we see now, it was not developed like that. And but I had the interest in my mind how to go for these dynamical theories of this, mind, so to say, or mathematical psychology. Now, I have been to different interdisciplinary fields, as I told, these electronics and communication leading to the bioinformatics, biological antennas what we find in nature, and then to cognition and consciousness, because there are lots of things we find in nature which could lead to the clues for our consciousness, perception, our memory, and all those things. So, I am seeking some answers to some questions. Maybe some parts you will find little bit intuitive. I tried to collect some of these mathematical formulas also, or formulae, to these different fields. the topic is From Quantum Uncertainty to Moral Choice, Defining Humanity Beyond Machine Intelligence. The question is now, as all of us know, we are using these AIs, particularly the teachers, we know, the students, whenever we give some task, they bring something. And also, we also do. Now, the question is, whenever we go for certain AI acts or activities, they are doing it very fast, better than us. So, from now, say 10 years, 20 years, because it is very fast growing, where would we stand? What would be the need of this human, this mankind? What do we do? Because these machines, they perform better than us. So, would it be, the position would come when we will be redundant? So, this is some of the basic questions what I feel today. I tried to accumulate here. Even some of the answers I do not know. It is left for you people. Some of the students I see, maybe you would be interested. And some of the things what we connected in different forms, I would discuss. So question is, the super intelligent era, whether that would make us redundant or not. And if not, where would be the roles? What would be the roles of us? Where would we excel compared to the machines? Okay? So, this I already had mentioned that this is basically an amalgamation of different approaches, physics, computer science and electronics. Because our life, we are not like only algorithms. Computer algorithms we will talk about, some of the principles we will talk about. And we would try to show or try to find out some limiting mathematical conditions which may govern or give some clue. Because I am talking about the consciousness, it may feel abstract. It may look like abstract to you, some of you. This figure I have, this photograph I have deliberately put in. One is Rabindranath Tagore in his youth, and another is in his old age with Einstein. Why I have kept it? One is I am from Calcutta, basically. Right now I am in Rajasthan, but I am basically from Calcutta. Second is, whenever you talk about this consciousness and all those things, maybe you have seen or you have read, a great debate was between Einstein and Tagore when they met in Germany. So, these philosophical aspects also would be required to understand or feel some of these questions, because maybe, I do not know whether you know this, maybe you have heard of Heisenberg, the quantum mechanics principle, uncertainty principle. When it was discovered by or given by Heisenberg, he was very, very unhappy. And that time somehow he came to India and he visited that time Tagore's place. He was in Shantiniketan, and they discussed about the philosophical part of that. And somehow he was quite relaxed. And this is a true story, true incident. So there would be a lot of things from the philosophy part of our, say, ethics, mind, and the social awareness and all those things, which would shape our cognition. So we would discuss about that also. This is the campus of MIT Rajasthan, beautiful campus. I would invite all of you there. It is a desert area, but you can see how it is maintained. So much of greenery, the hills and the lakes and all those things. My collaborators, some of them mentioned here. So Japan, Canada, UK, Malaysia, Bangladesh, some of them, they were well-known researchers. The overview of this, the human identity in AI era, then the physics perspective, computer science perspective, electronics and communication, and ethical and existential questions. So, regarding the physics perspective, we see we have heard of these entropies and all this. This is the disorder. So our system is an open system. Now in open system, it normally tends to be, this entropy would increase and all this, but there is a point that these open systems here, we would release our energy in such a way to minimize that, to become this, structured system, our body. Why? Because our thoughts are structured. So when we conceive something, they are not disordered, they are ordered. So entropy in one side, it should increase. Otherwise, whenever we make some, concise or precise thought or something like that, it should be ordered. So from a physics standpoint, humans are seen as a complicated system that resists disorder, shaped by the laws of quantum mechanics and thermodynamics. Concerns may stem from unpredictable processes in the brain's neural networks, unlike the predictable and efficient computations of machines made of silicon. Whenever we make some algorithms and all this, the predictable, digital. But when we talk about our thinking, our perception, our creation, they are unpredictable. The question is, why or how we would excel over the machines? Can a machine write a Shakespeare sonnet? Can a machine write, or in future could write or discover Einstein's principle or Tagore's song? Like that, this is the question. Because they are doing it much faster than us. Whenever they are given a task, they are doing it better than us. But the question is, what kind of task, what they perform. So we are giving them some task. They are doing it fabulously. They are doing it, very quickly. But what is the difference between our creativity and their performance? That should be the clue. So the presentation explores the evolving concept of human identity in the era of superintelligent machines. It brings together perspective, already I have told, what differentiates human from AI, emphasizing consciousness, problem solving, and ethical dimensions in a rapidly advancing technological world. Now, there is maybe you are students of engineering. I do not know, all of you. Maybe you would be a little bit intrigued when you talk about this consciousness and all this. But this is very important, because when we have some machine, the question is now is whether the machine could be conscious. Okay, maybe you have heard of that. There are lots of research going on how it could be conscious like that, like us, whether it could feel or something like that. So it could be some easy problem of consciousness. This memory mechanism, this attention, all these things are there, where we could tell this. There could be some algorithm it could detect and all this. But there is a hard problem of consciousness. Chalmers, he is a mathematician and a philosopher. He told that there would be some gap to find out these concept, the consciousness, the physical processes, it has some subjectiveness. That means I feel the pain. How do I quantify? I see the redness. How? Okay, so I see one apple. So I do not see the fragrance or the color or the shape. I integrate that and find a solution that this is an apple. So there is something underlying which is integrating all these things. Okay, so where is the correlation? What is the neural correlates? Because I will discuss a little bit about that, because these artificial neurons and all these things, then there are in computation, there are Turing principles and all this, will come to that. But the question is, where is the neural correlate? How to correlate them? So this is the hard problem. Now tell me, what do you see here? The students, if you can tell me, you can see, where is that one? Somebody can tell me how to use this? Anybody? Where is the switch? Only this red is not coming. No, I have to put that marker. This is the pointer. Where?
Yes, sir, this is.
Only this one?
Yes, sir.
This one, no?
Yes, sir.
Okay, fine. So tell me what you see here. Left hand side and right hand side. Which one is brighter or darker? Anybody? Left side means this one. This one is brighter, darker. Okay, from here I am seeing. Let me see there. No, I think this one is looking at the brighter side and this is the darker. But actually, it is not. Actually, it is same. Because of the background, it is like that. Because of the background, we are able to. It looks like that. That left side is. This is brighter and this is darker. This one. Only the strip. I am talking of the strip. But it is not actually so. What do you see here? But triangle is never there. So, your brain is making it. The triangle is not there, but you interpret it as a triangle. What do you see here? One girl behind the window. But who told you? There are different compartments, 4 different compartments. Who told you? Your brain is integrating this and telling you. Okay? So that means something is going on which should integrate your perception, your notion. And we are trying to find out the clues. There could be different things as clues. So we'll look for that. So this is the problem. Okay? When we talk about this consciousness and all those things, this is the problem. So, the physics perspective, as I already told, second law of thermodynamics, entropy, concept of disorder. So it should increase. But for open systems, it actively resists this by exchanging energy with that environment, importing order and exporting disorder through processes like metabolism. So, we are the systems, and if we want to make certain notions and all this, those are structured, they are not disordered. So, there should be some balance there. Okay? So, this is one of the key formulas for the open system. So, this mechanism, it enables humans to sustain low internal entropy. S equal to KL in W. So I think this you have studied in your previous one. So I'm coming to this. You see, whenever we throw some bricks, the bricks are there, they're in the disordered position, not like this. We are keeping something intact there. So it would be ultimately the gaseous system, there would be different molecules there. So this is the nature. Okay? It would be like that. The disorder would be more, it would increase with time. Now then what would happen? Then our system, over the million years of evolution, it would adjust itself. How? There would be certain structures in nature. Maybe you have noticed. These structures, they are fractal structures. Anything, everything, starting from the eye conditions, our body, the nose, hand and all these ratios, the galaxy, the leaves, say the fruits, you can see there is a fractal structure. What is the fractal structure? You can zoom in or zoom out and the same structure would be there. Now, why it is happening? Why? We will come to this with some of our research there. I will show that when this structure is complete like this, the resonance or resonant energy or the peaks are very, very powerful peaks we get. So it could be one of these clues how nature behaves. Now, this structure, say probably you have heard of Fibonacci structure in 1100 Fibonacci structure. So these, some of them are also obeying this Fibonacci structure. So 1 plus 1, 2, 2 plus 1, 3, like that. So this is found in nature. Okay, why? Because there would be certain reasons which would maybe to minimize the energy or maybe the robust structure or something else or the optimize the system and all this, whatever. So like this, it happens. This is one of the experiments of our the group. I am also working with Japanese group, Dr. Bandhopadhyay. This is one example of two microtubules. Probably you have heard of microtubules. Neurons you have heard of? So they are made of microtubules. Now the question is, these microtubules, when the experiment was performed, it showed that there would be wireless communication between two microtubules. You know about antennas, okay? Transmitting antenna, receiving antennas, you are getting these peaks, resonant frequencies and all this. So these are the microtubules. You can see there are 8 peaks. And I do not know whether you have heard of the Penrose hammer of theory, over theory. There is one theory, controversial theory, where the consciousness coming from gravity, it is collapsing and all this would come. So, to some extent, it is also explaining some of these aspects they are claiming. Now, this is the structure, you see, I have shown the lots of structures there. Even the Sanskrit mantras, there is a symmetry there. Okay, it was made in 1100. The Sanskrit structure of the Sanskrit mantras are there. So there is a symmetry. You can see, I have shown there, this structure, So how it is built. There would be some golden also, when you come for this, the golden angle, see golden ratio and golden angle there for this rotational part and all this. So these basically are the structures we find in nature. These are some of the some of our works where we had simulated different structures, and protein or DNA or wasp as we found in nature. So we find normally the antenna structures are there when we find out the electric and magnetic fields, the surface current. So we could get, and the resonant peaks. So they are very, very important because these things are useful for the for various cases. For the, first of all, the biological system, it runs from kilohertz to say terahertz, the frequency range. So unless we know which range you have to fix your instrument to get this experiment, it is very difficult to perform. So it would simulate and it would tell you, so this is the range of that, it's from the theory, and then we can design those experiments and all this. So these are useful for the nano drug delivery, so to say. I am giving you one example. If we know this electrical magnetic field or this surface current, say the cancerous cells. Now cancerous cells, these neurotransmitters are there or chemical drugs are there. You are using those drugs and it is somehow destroying that particular cell. But at the same time, it is destroying the good cells also. So there is a shift, paradigm shift from the chemical biology to physical biology. And lots of machine learning, artificial intelligence would be involved in that to analyze this data. Once we get this data, how to correlate it with this deep learning or machine learning. There are lots of scopes. So these structures, once we know, we could use for this, say, supramolecular resonance or something like that to send the energy. So that energy would directly go to that particular diseased site and it would not affect the other portions. Okay, so we have shown it like this for different proteins and all this, the same electromagnetic field and the surface currents. We'll use this later on. I will show you for some robots we had made. So where we had performed some experiments, say humanoid bot type. So this is, as I was telling, we had checked it with some simulation with a complete structure of some wasp. And we have found, you can check, this structure is gradually increasing, okay, complete structure. And we have found when we go to the final structure, the peaks, the resonant peaks are sharp and you see prominent electric and magnetic fields. So this is giving you one idea that when we go for this complete structure, whatever the way we get this in nature, this structure is somehow giving you certain optimization of this, maybe the energy, the fields, or maybe the corresponding resonant level, so that it becomes energetically viable or energetically there useful when we want to transfer something from there. So this is the interdisciplinary framework, humans as complex systems, already I have told. Then the computer science part, when I see the human thinking, it includes solving problems with no clear answer, that I told. When I talk about the creativity of the machine and the human system, so where we are different, creating new ideas and making moral decisions beyond just different problem solving algorithms. So I do not know the answer, but there is some uncertainty there. So my environment, my ethics, my moral characters, or whatever, the way we take, that would help us to answer that problem. For the machine, if it should be a defined one and it would give you some kind of, it would perform the task like that. But if there is no direct answer, so it's difficult. So then we have this electronic part, you can see, as earlier I told, there are different electronic system, brain-computer interface, we'll come to that later on. And there are certain limits or constraints which we discuss. So this physics already I have told. So this is the super intelligent AI limited by natural laws, London's principle. So which deals with the energy needed to erase information. It makes us question whether what makes humans unique is our inefficient but adaptable existence within the physical universe, or if machines could go beyond these limits through quantum computing. In computer science, humans are viewed as more than just complex programs. We are not programs. Our, the Turing machine, we are using to compute something. Who told that it is computable? What we are, trying to interpret, or what we are, the thoughts we are making, or the way we understand, who told that that is computable? It could be beyond computation. Okay, so we'll come to that. So there are certain entropy relations, already you know the standard entropy. So this is, it measures the uncertainty or the randomness in the set of information. Conscious mind actively reduces uncertainty. Okay, so by integrating sensory data, so forming coherent thought, that is the problem. Okay, so thus decreasing information entropy locally. So this is the relation with computer science. Free energy principle, it proposes that living systems, including the brain, are constantly attempting to minimize their free energy. A measure of the surprise or unpredictability of the sensory input. This can be viewed as minimizing information entropy, driving the system towards more order and predictable state. So basic point is it is more ordered. Okay, and it has to be because the thoughts are ordered. So we have this thermodynamic constant, these different thermodynamic constants are there. Super intelligence is a physical system, it must increase the total entropy of the universe. and it should resist the disorder. Already I told. So, like humans, a complex AI must actively maintain its low entropy, highly ordered computational structure. This internal order is sustained by consuming large amounts of low entropy energy, okay, and expelling high entropy heat into the environment. So, this is the way we could connect. So, already I have explained these things in the chart I have just mentioned. Now, the Schrodinger's negative entropy concept, because you know, in quantum mechanics, we normally for the calculations and all this, we use the Schrodinger equation. I'll come to that. So, this is the negative entropy. So, living organisms, it maintain their complex order structure by continuously extracting order from the experiment, the environment. Though through metabolism, energy intake reduces total entropy. Okay, so through hemostasis, ordered physiological states are actively maintained. So this is the free energy delta G. So this is the relation. Humans exist far from thermodynamic equilibrium. So constantly fighting entropy through energy consumption. So this is the guiding principle. Now, then the Lorentz principle is physical limits. So energy cost of information eraser. Superintelligent AI is limited by natural laws such as Lorentz principle, which establishes that the erasing one bit of extraction must dissipate a minimum amount of energy as heat. So the heat would be there. So you have to, that amount of heat is generated. So this fundamental limit connects information theory to thermodynamics and makes us question whether what makes humans unique is our inefficient but adaptable existence within the physical universe. Okay? Or if machines could go beyond these limits through quantum computing. So there you can bypass that energy part. Okay. So quantum mechanics and the consciousness, you see, this is the relation. I got del psi del t h psi. So we have to find out this psi. This is the wave function, and in terms of this wave function, we are trying to relate, in terms of the probability density and all this. So consciousness may stem from unpredictable quantum processes. So this is in terms of probability. There is, certainty in that. It could be this, it could be that, but there is a probability of everything. Okay. So this is how it is connected to the neural network. So, the Turing part I was talking about, I think I have time, huh? What's the time? Kitna time hai? So, this is, the Turing machine I am talking about. So, you see, whenever we are trying to prepare a notion, a brain is trying to make that. So Turing principle, as I was mentioning, that it tells that it could be, there could be some computation there. Now, based on that computation, we would make some notion. The question is, what I just mentioned, it could be beyond computation. Some part of the brain is making this. We will be trying to connect it with some theorem, mathematical theorem, so that the limits or constants could be addressed. Let us find out. Gödel's incompleteness and human intuition. Okay? So theorem, first theorem, any consistent formal system sufficient for arithmetic contains statements that are true but unprovable within that system. No finite set of axioms can capture all mathematical truth. Okay? So this is the first theorem, and the second theorem is no consistent system can prove its own consistency. So these are the mathematical limitations. So can human intuition grasp truths? Algorithms cannot. Penrose argues consciousness transfers from the system. So we'll come to that, but that is a controversial theory, but it is there. Then the halting problem. Given program P and input I, does P a terminate? This is probably undecided. No general solution exists. While machines can simulate any algorithm, human thinking includes solving problems that have no clear answer. And here we are different. Even if the answer is not there, we are trying to find out some way, and there lies the creativity. Okay, so the machine would be given some order, it would perform that. Whenever we are, trying to find out, we give a bias also, to solution and all this. So it is, normally we are giving some bias to that solution and all this. So then the EC part. So while machines can simulate any algorithm, human thinking includes solving problems that are no clear answer, creating new ideas and making decisions based on models which go beyond just solving problems efficiently. Super intelligent systems driven by advanced machine learning and the ability to improve themselves challenge the idea of what it means to be human by excelling at recognizing patterns and making choices. This leads to discussions about whether being human is about unique experiences, social behavior, or the ability to understand and deal with situations that don't have straightforward solutions. I have written this because I want the students to read this so that you can comprehend what we are trying to make. So electronics and communication engineering looks at physical tools that make all this possible. So in forms of these circuits and the brain-computer interfaces and all the biological meetings and all this, I will come to that. So you can see there is a difference, human, analog, and the transistor digital. Okay, so there is a fundamental difference there. Then Moore's law. These are some of the principles, basic principles, from electronics, what we are using. So what is the difference here? You see, human brain does not get denser. The Moore's law, what we are using. Here, it does not get denser. So there is a difference. Then, signal processing, analog versus digital. Here you have this, the full continuous signal for this analog, this part, and for this transistor only the discrete samples. Then the Kolmogorov complexity. Okay, so here also the high K means there should be more of disorder there, or complexity there, which should be lesser. So these are some of the things which you could relate from the domain itself, and we have to understand the parameters what could include influence. So this communication part, what we had simulated many of these the neurons and the connectome and different parts of brain for the whole brain, and these we used to make one humanoid bot. So I'll just show that. So these are initially simulated, and then we got these things, results and all this to make the system. So initially, these are the way, how we simulated and all this. So this is the one we were making, and different, antennas are there, these RF generators there. So again, we made some brain jelly, because we just pumped that brain jelly, because this is one interdisciplinary field, people from chemistry, physics, biology, computer science, electronics, and everybody were together, the large group of people we were there. So we were trying to make this and trying to pump some brain jelly and find out the response there. So these are the different parts. We made it, by hand, that's like that, integrated. So different structures, you see, different part of the brain. So these are the things, and we performed some experiments there, and also we tried to find out because there are lots of data, and most of the data not required. So what we try to do, we try to find some pattern in the system. Say a tiger is running, or say cheetah is running. Now, if instead of finding the whole data, because there is lots of data, our system would be, unnecessary using. If we can find out some pattern, means some invariant part of that, so you could locate that. So then we can tell, yes, this is this. This we can, relate with some particular kind of, say, behavior or motion, something like that. So we tried to do that, and we were examining particularly the motion of different, say, flocks, birds, and cheetahs, and all this. So there are, we found that these could be reduced to a very small fraction of the whole data we use normally for this, for describing the system. Because to find out the invariant part is not requiring that much of data. So I think what I was telling, this consciousness and neural, already I have summed up these things. So basically our difference would be not only the algorithm and all that part would be obviously the machine would do whenever you will tell them, but our moral, our ethics, our social awareness, these things would guide us to frame a certain notion, okay, and there we are different. So the limits of already we have mentioned, I've just made some points here to morality, ethics, and decision making. Okay, so ethical decision making, it involves nuanced consideration beyond logical analysis. Currently lack the intrinsic capacity for genuine morality and empathy, raising concerns on the role in society. Human ethical frameworks remain essential for guiding the responsible development and deployment of AI technology. So we have to incorporate that. Neural, already I have mentioned, high speed already mentioned, integration of biological and artificial network already I mentioned. Future prospects would be human identity thrives on uncertainty and adaptability, qualities that provide flexibility in unpredictable environments. Unlike deterministic machines, humans embrace inefficiency and change, which fosters creativity and resilience in complex systems. This adaptability is the cornerstone of continued human significance in a machine-dominated future. So it is not like that the machine would be, it is like the Frankenstein, and we will be all gone. Only the demon is there. So the integration of AI into society raises profound ethical issues, including privacy, bias, and autonomy. Addressing these requires a robust framework, balanced innovation with human values. Ethical challenges demand ongoing dialogue between technology, policymakers, communities, to ensure responsible AI adoption. Then the social and relational human values, already I mentioned. Conclusions are there, but after that also I tell something after the conclusion. So humans maintain uniqueness through deep connections to uncertainty, ethics, and relationship despite rapid AI advancement. Physical limits of machines and the complexity of human consciousness create distinct boundaries. The future coexistence of humans and machines depends on integrating these differences while preserving human values and identity. Why I am telling this? Maybe some of you know that Einstein's brain was preserved. It is still preserved. Why? Because people tried to find out what is special there, very special there in Einstein's brain. But it was nothing that different. When they examined that brain, they did not find that much of difference with our brain, normal brain. Only some more compartments or something like that. But that did not tell about anything, or that did not reflect anything about Einstein's brain, how it is so superior. So once it is out of the body, that is why this consciousness, it is so important that we exist. I am I. So that is very important. We are here, say, for 30 years, 40 years, 50 years, 90 years, 100 years. Before that, darkness. After that, darkness. So this part of time or this tenure, we are conscious. Okay. So this was experimentally, when it was examined, Einstein's brain, nothing of that speciality could found out. So that means when a living system we talk about, some magic is there which is responsible for all these things together. Okay, so overall, the study suggests that humans will continue not because we are better than machines, but because of our deep connection to uncertainty, ethics, and relationship in a world where machines are rapidly advancing. So, already we have mentioned this. Could be three scenarios: these optimistic, neutral, and pessimistic, where the machine will eat us up. So, coming to this last part, after the conclusion, this sense of self, I think couple of years back, Stanford researchers, they found a particular portion of brain where they found a region, which is responsible for, say, our I feeling. This is I. So where is that I? So that the structure they have found, which is, rising and falling in coordination with one another, indicating teamwork. So there is a structure which is, identified, or maybe they are trying to identify as the portion where the I part is connected. And finally, this is one. You can find it on net also. This is a story, not a true incident, but this is a sad story, so to say. Some person who was initially, a sober person, when it, rod pierced to his head, so then he became completely in nature, completely changed, he became a form of drunkard. Okay, so somehow this physiological change is responsible for his behavior. So this is something where it all are connected, your physical part, your mental part, and all these, things completely related, or we have to find out the clues, the hidden clues, where it is lying. So could it be the human consciousness, the help of quantum computers? Could it be something where the resonators of these hidden structures we have already told, they may reflect, where the consciousness lies, or the memory lies, because they are not clear. Still the information unit is not clear, you cannot quantify that. So it is subjective. So that is how the mystery lies there, and we have to address this problem through all these fields: physics, electronics, computer science, physiology, psychology, mathematics. So all these fields together would give maybe a clue in the future years. Thank you. Any question? Any questions? Anybody? No?
Yes, sir. Ma'am has a question.
So that was a completely insightful talk, and I'm highly privileged to be an audience to you. So my question is just as you concluded, and you said that it is the existence of the human depends upon the way he can deal with uncertainty and create information which machine cannot. A machine can only be trained on the existing information, cannot create data and information. That is the job of humans, and that is where machines cannot replicate human brains. So if the technology is going so far, and things are being developed and technology is being modified, so will it not be in very far future that this gap is also filled somewhere, where machine is able to create data as well, with the science and technology going ahead? So do you think that this is going to be somewhere achievable?
See, already I told you, if something is, the Gödel's completeness theorem and all this, somebody is in part of, please sit down. So if it is part of that, it cannot be consistent with this whole part. Whenever you are making a subset of that, our brain is trying to make this. Okay. Now, whenever we are talking about this creativity and all this, you see these new AI methods and all this, maybe it would more include this probabilistic part. You could always build in those parts. But the question is whether, my question was fundamental, whether it could write a Shakespeare sonnet, or it could write a Heisenberg principle, or it could create something, either on Einstein's theory or Tagore's song. So question is there. So whenever we are training them, they would be able to do that faster. But where these answers are not known. These answers are to be found from certain factors, not only from algorithm. Not only from algorithm. Because who told these things are coming as some byproduct of the mathematical parts we are doing? No. There is no algorithm, no solution, completely intuitiveness. So maybe the higher order, something which is coming as an envelope of that, it is somehow coming to the lower order and giving this representation of that, whatever the notion or thought with there. It could be something, some soliton. Maybe the soliton is made there, which would move through with compactness of that soliton. The wave structure or the structure of that soliton is not changing. So once you want to make some notion or some thought, it has to remain there in that compact form. Now, coming to the second part, or maybe the first one question was on a single question, but the second part, what you were talking about in future also there could be some gap, what I feel, because from the mathematical point of view, there are certain constraints which we cannot overcome through our mechanisms. So this is the way we would live, and we would be, instructing them. Maybe it would be working in better, speed, in better complexity. People are trying to find out, this consciousness in the robots and all these things. But why, or whether it would be the same, the way we feel? Because of that, I given the example of Einstein's brain. Something is out of this living system, is completely devoid of that divine factors and all this, what you so to call.
So that means that gap can never be filled.
I think.
Okay.
Because that's why I connected all this mathematical part. Some are intuitive, some are giving you some limitations and all this. So if it is like that, then the machine would, when it outperforms us, then we would be redundant. My question is that, whether we will be redundant, then what would be the purpose of us?
Yes.
What for we will live? So I would love to believe that we would be having some part to play in this world. Otherwise, the machine would do everything with Frankenstein.
Yes. Thank you so much.
Thank you so much, sir, for being the guiding light of knowledge and empowering us through meaningful insights. Your ideas have truly broadened our understanding. We are honored to cherish this moment and present a token of gratitude, a moment that symbolizes our respect and admiration. Now may I request our respected Director, Academics PSIT, Professor Vishal Nagar sir, to present a memento to our esteemed keynote speaker. Everyone, please give a big round of applause. Thank you so much, everyone. Now I would like to request all the respected dignitaries, faculty members, and all the guests to proceed for the lunch. And we are going to assemble here again after lunch. Thank you so much, everyone.